Hello everyone, welcome back to my YouTube channel. In this video, I'm going to share my learning notes about Cron-Job using Kubernetes. And then we are going to play around with it using a tool called Kind. So without further ado, let's get started. So in this diagrams, I'm going to show you a component scope of creating Cron-Jobs. So if you see the far left, we have pod. Pod is basically a component in Kubernetes that will run or execute our containers. And the behaviors of the pod will be configured by the job. So job is another component of Kubernetes. Its responsibility is to manage different kind of configurations, as you can see in the slide. So if we execute job, it will eventually create a pod based on our configurations. And to execute the jobs with schedule, it is a responsibility of another component called Cronjob. Right. So basically, Cronjobs manage this kind of configurations like time management, job duplication, and retention of past history. So these are three components that play an important roles in creating of cron jobs. Later on, you will see when we are looking on the configuration file, we will able to see which configuration is belong to cron jobs and which configuration is belong to job. Right. So this is the Kubernetes component scope for creating cron jobs. And what is Kind? Kind is Kubernetes in Docker. So it's basically tools we can download, install locally in laptop, or maybe we can set it up for our continuous integration pipeline. So it uses Docker to simulate nodes. So it runs the Kubernetes nodes inside Docker. With these tools, we are able to spin up multiple nodes, multiple clusters. Of course, it works offline, and because it runs using Docker containers, it should be fast and lightweight. All right, let's go to the first demo where we are going to set up Kubernetes clusters using Kind. Okay, in demo one, we are going to set up clusters locally using Kind. Before that, there is a prerequisites. You need to install Docker first if you haven't, or Docker desktops. And then you need to install kubectl tools if you haven't. And then this is optional. This is a tools to help you switching context and namespace easily. kubectx and kubans, but this is optional. Just in case you already have gcloud CLI tools installed, you can install kubectl by running gcloud component install kubectls. Right, it will install kubectls for you. All right. So in my case, I already installed all of it. Right. I have Kind version 0.17.0. Should be the latest version currently. Right. So to create clusters, the command actually really simple. Kind create a cluster, and then you give it a name like this. Right. The name is optional, but I like to give it a name for my clusters. If you hit enter, you can create a single node clusters. All right. But for this demo, I'm going to show you also how to create multi-node clusters. To do that, you go to Quick Start. All right, and then you go to Advanced sections. There is multi-node clusters installation instructions. So you just need to copy this save it in the YAML files. I already have with me this one. So let's take a look. Kind multi-node config YAML. So I want to create a clusters with 2 nodes. The first node will have role control plane, or if you uh, learning Kubernetes from learning a resource that created maybe a year ago, uh, this is actually the same with master role, but recently they changed the terms from master to control plane. And the second one is worker node, which is basically the node that will execute your pod, your container. Right? You need to save it, and then you can run it. Then you specify the config locations. In this case, kind multi-node config YAML. Hit enter, and what you need to do is just waiting. Since kind will use uh, Docker containers, right, for the nodes, so should be faster. Yeah, to spinning a new cluster, a new node should be fast, right? So currently I try to join the nodes because we have 2 nodes, and yeah, this is done, right? So you can check the Docker container. We should have 2 containers, which each for nodes that we just set up previously, right? So we have 2. The first one is for our control plane, and the second one is for our worker. Nice. And then if you need to configure the nodes configurations, you can just access the containers and tweak the configuration there. For example, I want to see configurations in these containers, so we can uh, access it by this command. All right, this is the container ID, and then we're going to access with shell, and then the configuration file is located at etc/kubernetes. Right, so this is the configuration file of the worker nodes. Cool. Now let's check our nodes. Let's switch context first to local. Now his name is kind local Steve. Right, the context has been switched. Now using kubectl get nodes. So you can see that we have 2 nodes. Status is ready. Roles is control plane, and the second one is the worker. Nice. So up until now, our cluster is ready. Next, we are going to create a cron job and run it in our clusters. So that's it for the first demo. Okay, so after we see that demonstrations before, the next one, we are going to jump into the cron configurations or manifests. This is basic cron configurations. Right, I will use my pointer. So the first one is basically the API versions of creating crons. The kind is Cronjob, and then we have metadata name hello. So hello will be our Cronjob name, and it also will be determine the pod name. Under the spec, we have schedule. So I put color yellow because this is Cronjob level configurations. This is where we schedule our cron jobs using a cron expressions, right? So you can use a website called Cron Guru. That's very popular one, right? Just use that and then put here, it will work, right? So they use the same cron jobs syntax. And the green one, job template, is a template to create job. So anything underneath job template is job level configurations. And here we specify the containers. The name of the containers is hello, and then where we get the image. In this case, the image is BCBox version 1.28, and there is image pool policy. If not present, it means that how Kubernetes service pull the specified image in the node, and there is also restart policy never, which is how should Kubernetes service restart the container on the node. So we are going to check about these two configuration in the next slides. And oh, by the way, this configuration is in YAML, right? So about job image pool policy, this is basically we define how the node the pod pull the image, right? So always, if we set the value always, it means that Kubernetes will always pull the image from the repository. If we set if not presents, means that Kubernetes will only pull the image when it does not already exist on the node. The third option is never, which is, yeah, it will never pull the image. All right, and this slide is about job restart policy. It means that how should Kubernetes service restart the container on the node. There are three options that we can put as a value. The first one is always. It means that the container will be restarted even if it exited with a zero exit code. This is useful if you have a long running applications, maybe like HTTP server that should be kept running regardless the status code. Second one is on failure, means that the container will only be restarted if it exited with a non-zero exit code. Or the third one is never. The container will not be restarted regardless of why it exited. So it gives you options of the behaviors of your job, or in this case your cron jobs. What happens if your application return an exit or not? Should we try to restart or not, right? You should choose based on your own requirement. Let's go to the second demo. In this demo, we are going to create Cronjob with environment variable. Okay, so let's start the second demo. In the second demo, we are going to create a simple cron jobs. Right, so let's prepare the container first. So let's build one. Uh, let's give it a name, Docker file. Konnichiwa. Let's uh, let's use Alpine. Let us. So the command will be very simple. Echo konnichiwa space name. So the name will be an environment variable that we're going to pass from the Kubernetes configuration later. But for now, let's try to build uh, this one, konnichiwa. File is in Docker file, konnichiwa. All right, let's test it. Docker run min e name. Let's say look minti konnichiwa. Konnichiwa look. Great. So we already have the containers. So we need to load the image to Kubernetes node. So to do that, we use kind load. Sorry, I forgot the command kind load docker image, and then the name of the docker image konnichiwa. Min name to our cluster with name localhost, right? Enter. There you go. So the image has been loaded. Now let's create the cron job. So let's create a YAML file. Pimp cron konnichiwa dot YAML. Right. So the content, if you've seen the slide before, we have this cron jobs manifest, right? Or cron job configurations. From this, we are going to modify a little bit. So the name, let's change to Konnichiwa. So this will be our cron job name. Also, our pod name will be derived from this metadata.name. And then the name of containers, yeah, just give it Konnichiwa, and then the image is from Konnichiwa, right? Because we have load the image, so we just put here. So if you put your image in the repository, you probably want to, to use a link to your repository, yeah, if I'm not mistaken. But I will check it. Yeah, I'm not really remember, but I think you should put a link to your repository. So yeah, that's it. But I'm going to give another extra configuration here. So inside the containers, I'm going to add a name, sorry, env, right, like that. Env configurations, and dash dash space, dash name, right? So this is the name of the environment variable. Uh, we used name before, and then the value. The value. Let's use my name, Steve. Just check. All right, this is valid YAML. Copy this one to our configurations. Save it. Boom. So now we already have our YAML file for the crons. Let's create the cron jobs using kubectls create minaf cron konnichiwa. Right. Now before I enter this, I'm going to create a new tab. Yeah, I think it's enough. So in the second session, I'm going to use command kubectl get cron jobs. Wait, cron jobs. Yeah, okay. So kubectl get cron jobs mean watch. So I will listen to any live update for new cron jobs, and in the second tab, I'm going to create a new one. Right. So once we enters, it will register our cron job here. Right. With the name Konnichiwa, the schedule is every minute. Let's wait for the next minute. While waiting, we are going to check the pod, get pods. I think get pods. Yeah. So you can see that we have one pod created with status completed. It means that it already completed the job, right? You can see here active is one, right? If I close this, switch to get jobs instead, right? You can see that this is the jobs, right? The cron jobs and then the jobs that creating this particular pod. You can see the UUID here, the same, 292, 292, right? And then we can check the logs, kubectl logs from this pod, right? You can see that it prints Konnichiwa Steve. Steve is the one that we set in the configuration before, right? So we can kill or stop or remove the the job, yeah. If you want to completely remove, we can use kubectl remove min f and then our configurations cron konnichiwa yaml. Oh, it's not remove, sorry, delete. Right, so it's deleted. All right, so if we get the jobs again, all right, there's none because we already delete. Cron jobs, none because we already delete. Pods, none because you already delete all the jobs and cron jobs, right? So that's the second demo. Okay, let's continue with cron job history. So when your job is being executed, it can be successfully executed or failed, right? And there is an options to keep the pod from being terminated. So let's say I want to make my pod remain there. So please do not delete it if the job is success or maybe failed. For what? For debugging purposes. Because if the pod is terminated, deleted, you cannot check the log directly from the pod, yeah. But if you put the log somewhere, let's say to log aggregator, yeah, you can check the log, but you cannot access the log to do debugging further. So there is an options to do that in Kubernetes by setting these options, yeah, successful job history limit and failed job history limit. So this is optional fields, and if you do not specify this by default, the value will be 3 for successful job history limit. It means that it will keep the last 3 pods of successful job, and for failed job, it will keep the last one uh, pod that failed, yeah, so you can debug it for later. So this is a very nice options that I think you should play around with it. Next, I have another options, active deadline seconds. All right, this is in the job level, yeah. Previously, this is a cron jobs level configurations. Now in the job level configurations, active deadline seconds is basically we put a maximum seconds, maximum durations of the job executions in seconds, yeah. So if the job exceed the deadline that we set, it will terminate the pod. This one will directly terminate the pod. So even though, let's say you put these configurations, let's say to 1 or to 2, but if the jobs is exceed this deadline, it will terminate the job. So you cannot really uh, check directly from the pod. It's gone. So therefore, in the demo 3, we will see how to handle long job executions, yeah. So how we should write our job executor so that it can handles when Kubernetes want to remove the pods due to deadline exceeding. Hey guys, in the third demo, we are going to run a long-running cron jobs. It will technically never-ending jobs, and then we are going to kill it using the active deadline seconds. So the applications, I'm going to use Go. Here I have a simple code which is basically will print this string per 500 milliseconds, and it will never ending, right? So we are going to check the behaviors of the applications first with these conditions in the main file. So ignore the commented code, just use background context and execute the long running jobs. All right, so this is the CMD where I put my main files. So let's build our application first. env, right? Because our applications will run in Linux, I need to set to Linux when building the Go files. the Go files here, cron demo. I don't like the name. I'm using ticker as a name. Right, there you go, ticker. Let's run ticker. Oh, yeah, I'm sorry. It will not run because I have set the OS to Linux. So let's create Docker files. Vim Docker file. Let's use from Alpine latest. So we are going to copy our ticker binary to bin/ticker, and then basically we will run that binary like that. Okay, so docker build minty ticker. All right, dot. All right, let's test it. Docker run minty ticker. All right, it runs. It will ticks every 500 milliseconds endlessly. Kill it. Right, so we have to load the image to our clusters, to our nodes. Kind docker, oh sorry, kind load docker image. Right, it's loaded. Now let's create cron-jobs. So let's begin. So if you remember, this is our Konnichiwa cron-job configurations. I need to modify this a little bit. So let's create, no, let's modify the name, ticker, ticker, yeah, let's say ticker, and then let's change this to ticker also, and then this is to ticker. This one we don't need it for this case, so let's remove it. Alright, so we are going to add active deadline seconds, and if you remember, it is a job level configurations. So we should place it under the job template. So under the job template spec, and then we should put it here. So let's put it maybe 5 seconds, or maybe 10. Yeah, let's put it 10. Yeah, validate, good, copy. Now let's create the configuration file. Let's create a theme cron ticker.yaml. Save it, and then let's create the job. Right, so to create the job, the command is kubectl create cron ticker, right? And as usual, in another tab, this time I'm going to watch for the pods. Let's execute this, right? And then I will see the logs from the generated or created pods. This one, let's put it here. Oh, oh, it's terminating. Min watch, right? Oh, it's not min watch, min f. Yep, it's already terminated. Wait, I need to wait for another minute. Here you go. There you go. We have the tick lock. And then once it's terminating, right, terminated, the pod is gone. Kubectl get pod right? It's not found, it's gone because it's terminated. So we cannot check the log. We cannot debug by accessing the pod, right? So let's kill the cron for now, right? Oh, by the way, this command kubectl logs pod name minf. Minf means follow, so we follow the new logs. So what we can do to improve our applications so that when the jobs before the pod is terminated, we can at least shutting down gracefully our job executors. So in the documentations, right here in the documentations of pod lifecycle, there is a section of terminations of pods. So if you read this, basically, Kubernetes will send a term signals, yeah, to tell the main process in each container that the pod will be terminated. And then by default, we will have a grace period of 30 seconds to do graceful shutdowns. It can be shutting down connections, closing files, etc., whatever we need. After 30 seconds, it will send a signal kill to terminate the pods. So we can utilize this in our applications. So back to our applications. Let's uncomment this one. So this code basically will listen to signals of terms, and then when receive the signals, it will cancel the context, and the context is being used here in the long-running jobs. So when long-running jobs receive that cancellations context, we will stop the tickers and returns an error indicating that the context has been cancelled, and then we are going to print the errors here. So after canceling the context, we do some shutting down operations with this context, and the context has a deadlines of 30 seconds, which is the default ones. For this example, I just print shutting down like this. All right, so let's save this. Yeah, this is already saved. So let's rebuild. No, let's build a new one. This one. Let's build a new one. Min old ticker. Let's say v2, right? v2 with the graceful shutdown. Let's uh, let's update our Docker file, right? So we copy the v2 to ticker v2 and then run v2, right? So let's build Docker build ticker v2, or you can use this tag here. Well, I never used this before, so yeah, let's use this. Docker build. Oh, it must be lowercase. All right, never mind. Kubernetes clusters. Don't forget to load the Docker image. Ticker v2. Cool. Now let's create another cron ticker v2. Let's copy from here. Right, copy from there. Right, name ticker. Oops, v2 ticker v2. Right, ticker v2. Let's put it 20 seconds for now. Right, now we need to watch the pod, and then let's create the cron job, create, and then specify the configuration file like that. Cool. Let's uh, logs. Let's wait for the pod to be generated. All right, there you go. Copy that. Right, So let's wait for 20 seconds. Alright, so after 20 seconds, when the pod terminating, it sends the signals and our application receives the signals, and then we are able to exit the code gracefully and then print the error log. So we can debug why our code is failing, something like that, right? Okay, so that's the end of the video. I haven't covered all of the configurations. There's still a lot of it, such as parallelisms, retry mechanisms, but I've put all of the links in the video descriptions for you to play around. I hope you enjoy the contents. I see you again in the next video. Until then, stay healthy and keep learning.